Hello everyone, I'm Nicholas O'Brien, and today I'm going to talk about Unlearning Unity, Godot for the solo developer. This talk is modified a bit from a workshop I did with Baby Castles Academy, so shoutouts to Baby Castles. I realize that the title of this video and talk is maybe a bit provocative, so I wanted to explain why I'm advocating for solo developers and small studios to consider making the shift to Godot, and to outline my own rationale. The first reason is that I've been developing on older hardware. I don't have a super high performance AAA approved GPU, and I want to avoid the feeling of needing to catch up to make sure I can run the latest update of Unity. The next reason is that I've been feeling super alienated by Unity as a company lately, and I'm not going to dwell on this, and you can make your own conclusions about what I mean by this, so I'm just going to kind of leave it there. Another reason is before learning Unity, version 5 or something like a million years ago, I first learned Blender. I'm really inspired by the Blender community. The artists and educators advocating for the software, they've had an incredible and serious industry impact, and I feel like Godot is about to also cross that threshold. The last and maybe biggest reason is that I was feeling super bogged down in the development process using what I felt was a partially imposed methodology for how to make games. But really, I was just tired of this. Or accurately, I was really scared of this. I feel like after I finished my last project, starting a new project in the software just felt dreadful. My last project took me over 2.5 years to make, but its structure and design was really simple. Making something more complicated and technically ambitious felt near impossible. Even after doing some pen and paper designs and prototyping, I would stare at this screen and think, where do I start? This brings me back to my last point in the why section from before. This fear and anxiety that I experienced was stunting my excitement for game development. I admit that this constricting feeling shouldn't be seen as a universal indictment of Unity being bad or poorly made, even if it is. But I wonder if its architecture and design paradigms made the process of making games no longer fun. For me, as a solo developer, Godot fixes this. In a lot of ways, I feel like a subtitle for this talk could easily be Rediscovering My Love for Iterative Development, because at its core, I feel Godot encourages that game design pillar more effectively than Unity. Using Godot returned me to a state of joy by allowing me to see how something large and unwieldy, like an ambitious game project, could be broken down into simple, manageable parts. For the rest of my time, I'm going to discuss the key architectural and maybe philosophical differences I've experienced between the two engines. I'll also run through some core concepts to translate from Unity to Godot, and then outline some brief pros and cons of using Godot as a solo dev. Okay, let's start with the architectural differences. The core design principle of Unity is that it brings together game assets from other software, 3D models, music, sprite sheets, and turns them into game objects that can be manipulated and expanded using a combination of components and scripts. Godot's design system differs in that the architecture is centered around specific node types, and that those can be extended also using scripts. So unlike generic game objects that can contain different types of functionality, nodes in Godot have specific set behaviors that can obviously be modified. So I'll get into these differences later, but the reason why it's important from a design perspective is that building a game in Godot's node system actually makes the design methodology more modular, flexible, and in my mind reinforces the importance of iterative development. Instead of making game objects that have the potential for being any number of different things and potentially becoming bloated with functionality, Godot sets some limitations on what certain nodes can do. But what appears as a limitation actually becomes a process of deliberation, discernment, and intentional design. Godot's node system lets developers workshop and prototype small pieces of functionality without needing an entire system or scene developed to test out those mechanics. It also means that in Godot, the hierarchy, or tree as it's called, actually matters. The relationship between objects are not merely parent-child grouping arrangements, but the way things are nested together actually has functional significance and increases legibility of how the engine actually works. Let's take an example. If I were to start the process of making a 2D side-scrolling game, in Unity I'd start with slicing up the character sheet, creating a tile map, adding collision, making sure my input system is assigned, and then starting work on C# programming. Now, I could do a lot of this without actual artwork, right? I could cut the character sheet and use the 2D sprite component and use simple color grading or color blocking or gray boxing to prototype. But I'd still need to have all of this stuff set up, including colliders, before even starting to build out the movement functionality. In Godot, I could use a kinematic body node and attach a placeholder 2D sprite node as a child, turn off the world gravity for now, and get into programming in GDScript. I wouldn't need to worry about colliders yet, or mock up a simple level, or make any other game objects. This architectural difference of making the individual pieces of the game building process more discrete, iterative, and intentional amounts to a philosophical difference between the two engines. In Unity, game making requires a lot of pre-production labor and scene setup that potentially might even get scrapped or never even used. And to me, that intensive foresight can make the development process so much more stop and go. Godot, on the other hand, allows developers to focus more acutely on one task at a time. For a solo developer who might be wearing multiple hats, art director, programmer, level designer, production manager, the ability to focus on specific ideas can be incredibly rewarding and, in my experience, much less stressful. After completing and prototyping one idea or a mechanic, Godot's node architecture then easily allows you to fold that work into larger scene files without the frustration of linking assets, in-engine loading, or trying to sort through a million game objects to find that one script you want to extend. So with these architectural differences in mind, it might be a bit tricky for folks to switch brains to an unfamiliar mindset. To assist in that process, I've outlined some key concepts that I think are important to translate between Unity and Godot based on my experience. The first one is everything is a prefab. In Unity, game objects can be turned into prefabs that can be instantiated multiple times and come bundled with preset components, attributes, and behaviors. A typical example of this could be a coin or a collectible object or an enemy. Prefabs can be edited so that all instances of the object can then inherit that new behavior or variable. This process can obviously have a lot of upside, and recently Unity has included nested prefabs, much to the excitement of the user community. In Godot, every tree or node can be instantiated like a prefab. If you make a custom tree for your player character, you can then import that tree into your scene, or add an instance of it to your scene tree during gameplay. Like a prefab, instant nodes can come bundled with all of the children of that root. Again, this makes the process of focusing on one specific object, scene, or even entire behavior much easier and allows for agile development. Though everything is a prefab, the way that you instantiate your nodes and scenes leads me to another important concept that should be discussed. In Godot, you use resources instead of assets. And though this might mainly feel like a semantic difference between the two engines, an important difference is that if you want to instantiate a resource into your scene, you need to load it first and then add it to your scene tree or hierarchy as a node. This took a bit of getting used to when I first learned GDScript. And although it's not a major design concept that requires translation from Unity, I still think it might be useful for understanding how Godot's architecture is structured. The next concept is one that might be a bit evident by now, but I think is important to make explicit. There are no components, only nodes. Instead of adding a collider component or a rigid body component or an animation component to a singular game object, you create a root node that has each one of those behaviors as a child. This might seem a bit inefficient at first. Instead of just making one game object, you're loading a bunch of multiple nodes. But functionally, and as far as I can tell performance-wise, that makes the process of adding functionality and extending game mechanic behavior a lot more legible and flexible. Also allows for the functionality of one node, say a timer node, to not only affect its parent or siblings, but also affect other nodes in a larger tree structure, and we'll get to that. Also, nodes can be activated and deactivated without potentially creating errors in the root. It saves a bit of time needing to fuss with a bunch of different and, at times, interdependent components. So the rule of thumb that I've applied to this is there's a node for that. The fourth concept is related to the last one, but I think it bears a bit more specificity. So there's no canvas, there's only control nodes. In Unity, to make UI or HUD objects, they should exist within a canvas layer that's rendered in front of the camera at all times. In my mind, these objects are always designated as existing somewhat separate from the rest of the other game objects in the scene, even if that's kind of inaccurate. In Godot, there's a dedicated 2D workspace where you can assemble, edit, and test all of your UI elements, as well as design your 2D games. Control nodes then can be instanced in a main project scene without needing to be organized with a specific canvas object, although there is a canvas layer node that can be helpful in organizing ZSpace. The fifth concept goes back to a point that I was making about how nodes speak to one another. So instead of getComponent, Godot uses signals. Signals are a pragmatic way to alert nodes that events are happening or happened, and to change or start behavior based on those events. In Unity, developers would use getComponent to modify data between game objects. Though this can be a really efficient way of doing things, it requires a programmer to know precisely what variable and property in a component needs to be changed. And I frequently have to dig through the APIs to find the correct syntax for changing the properties of, the Cinemachine virtual camera variables. Godot uses signals as a more elegant way, in my opinion, of communicating between nodes. Though many nodes have built-in signals that you can use to trigger events, you can also write custom signals that can trigger code in other nodes in your scene. The nice thing about that is that you can set up all the signals you want before implementing your other nodes, and the code is fairly agnostic when it comes to signaling an event. So you can set up all the signals you want to emit during something like a collision prior to any of those nodes being in place to receive those events. In my experience, signals work best when paired with groups, Godot's system for tagging and labeling nodes. You can create a signal that says go find all the nodes in this group and run a function. Or when the signal is triggered, find nodes that belong to this group and change something about their behavior. Again, you could do this prior to those group nodes even being created, and Godot will allow you to build this functionality without throwing any errors. The sixth concept took me a bit of time to fully wrap my head around, and I think I'm still trying to figuring it out. In Unity, you have collision components. In Godot, you have physics layers. Collision is obviously an essential aspect of game design. It supports everything from triggering events to ensuring a physics engine runs. In Unity, you can give collisions to pretty much every type of game object, even empty ones. Unity actually makes physics simulation quite simplified right out of the box. But to get the physics and triggers of Unity to work discreetly, you have to write some C#, which is albeit pretty standard stuff, to properly check your colliding objects if you want certain behaviors to be executed. Godot breaks this out to be a bit more detailed and, again, intentional. Instead of applying collision components, you assign two specific variables within the collision node to set up their behavior. These variables are the layer and the mask. The layer tells the engine what physics layer the node exists within, or is tagged by, and the mask tells the engine what physics layer the node can interact with, or collide with. In addition, Godot breaks down the types of collision into two types of nodes: its shape and its type. You can have a static node with collision shapes wrapped around a 3D stationary object, or trigger areas, a different type of node, that use a sphere shape for triggering events. Breaking down the way the engine interprets physics and demarcating objects as static, kinetic, affected by gravity, or operating as a trigger, and then assigning those nodes to the correct layers can, admittedly, take a bit of getting used to, especially for 3D objects. But breaking out these behaviors into respective nodes allows for a lot of difference between, different objects existing within the same tree, but being affected by the physics or other nodes of that tree in radically different ways. The last concept is a bit more advanced and has to do with data management. In Godot, there are no scriptable objects. I felt like one of the handiest things that I used when designing my last project was using custom assets with scriptable objects. I use scriptable objects as quote-unquote data buckets to store, track, and check current game states, and to use those states to update information about where the player is within the narrative, as well as create debugging shortcuts to inject player variables into the game to test specific sections. Scriptable objects can be used for so many different things, but I find that something that they're really good at is data storage, management, and retrieval. To accomplish the same task, I used a combination of creating custom resources and singletons in Godot. Singletons are preloaded scripts that exist within the root of a scene. They are scripts that get loaded into a node the moment a scene is loaded, and those scripts can contain data, obviously, that can be changed, pulled from, and modified throughout gameplay. A custom resource is a resource created from a script that contains custom properties, and they actually are very similar in design as scriptable objects. So one way that I've been using this method is to create a master controller singleton or resource that stores data of the game's current state, and for other nodes to read the variables in that singleton and to update them when the state of the game changes. This method could also be accomplished by creating a plain node with a script attached to it that persists throughout scene changes, but you'd have to account for this every time a scene tree is changed. This way, the singleton is always loaded into the root, regardless of scene changes and new trees being loaded or unloaded. Or better yet, a custom resource within a singleton can add even more customization and operability. Okay, as a quick summary, the main concepts I just outlined are everything is a prefab, i.e. nodes replace game objects but operate more similar to prefabs. You use resources instead of assets, and you need to both load a resource and then add that loaded resource to a node. In Godot, there are no components, only nodes, or, as I said, there's a node for that. There's no canvas, just control nodes. Instead of getComponent, Godot uses signals, as well as using groups instead of tags. Collision is assigned using physics layers and determined by a node's layer and mask, as well as its type and shape. There aren't scriptable objects in Godot, but singletons and creating custom resources behave in a similar way when working with data storage and control. Okay, now let's move on to the pros and cons of working with Godot before wrapping up. Okay, so for pros. The first thing is that I find Godot to be very iterative development friendly. As I've discussed over the course of this video, the node architecture of the engine encourages a workflow that allows solo developers to concentrate on specific functionality without worrying about end use or in-demo implementation on the onset. Because of this, I find that Godot is very flexible and scalable. I haven't really talked about this, but Godot's default programming language is GDScript, a variant of Python, and it has custom syntax that compiles on the fly and gives incredibly responsive feedback and debugging. But also I find GDScript more forgivable than C#. I'm not a computer scientist by any means, but I feel like GDScript's variable flexibility made me always feel like, well, let's see if this works, in an exciting way that I wasn't feeling in Unity. I'll admit that my game design and programming experience might have given me a leg up when making the switch, but I honestly feel like the learning curve of Godot was a lot more accessible than Unity. Also, the documentation and community resources are truly comprehensive and excellent. I find Godot holistic as a piece of software. There aren't ancillary features, loose ends, unmaintained code, or unsolvable buggy issues that I've encountered so many times in Unity. To borrow from a programming term, it feels way less kludgy than Unity. All of the features seem fully integrated, and the software feels responsive to its users' needs and desires in a way that Unity just doesn't for me. Godot is lightweight. It opens fast, it responds to commands quickly, it compiles on the fly, and it just runs great. Sure, I've encountered a couple of crashes here and there, but it's mostly because of my own foolish inputs. I ran Godot on a Chromebook for a while, and it did great. It ran very smooth, the editor was very responsive, the integrated IDE is minimal and stripped down compared to the bloated Visual Studio. It's compact, efficient, but also very powerful. Also, all of what I just said improved in Godot 4 as the renderer migrated to Vulkan. So it'll run even better on all kinds of hardware. And for me, tech accessibility for game designers just getting started is a huge overlooked issue. So maybe you can tell I'm enthusiastic about the engine, but I'm not alone. The Godot community is excited about the development roadmap, and recent improvements to quality of life operations in 4+ have made the community not only feel heard, but also active in the feedback process. Which leads me to my last point. Godot is open source. You'll never need to pay for a license or give kickbacks if you make something that sells over a certain amount of units, or worry about the company turning into an IPO or whatever. Okay, those are all great, but what are the drawbacks? Godot right now doesn't really have AAA photorealistic rendering. Yet. There's been some really promising demos that maybe some of you have seen, but on a whole, those snapshots are mostly pre-baked light mapped areas, and to scale those effects would be beyond Godot's current rendering pipeline, in my opinion. Vulkan might solve some of that, and I know that there's technicians out there right now doing all that they can to make Godot's render compete with the likes of Unity. A big drawback that I found is that while you're working on your HUD or UI, you can't actually see what those control nodes will actually look like in-game until you run a test build. In Unity, right, you can see how the canvases look in the game view right away. And although configuring a canvas to be flexible with different screen spaces can be a bit of a hassle, you can at least test it out a bit quicker than Godot. Another con for Godot is that you can't tweak code or debug an issue while the game is being played. This is because when you run your game in Godot, it actually makes a temporary standalone build. So even after tweaks and updates, you need to restart your build to see if what you changed works correctly. Though I think this could be an issue for much larger games, my solution to this has always been to use iterative development tactics to try to fully develop an aspect or a mechanic first before trying to integrate it into a larger project. Again, modularity is always going to be your friend in Godot. I love GDScript, but for folks that are used to visual scripting paradigms, whether it be Bolt or using shader graph, Godot doesn't come with these features out of the box. And I know that there is a plugin for doing shader graph like visual scripting for materials, but I don't know how much maintenance and support it's regularly getting, and I could be completely wrong about that. I really don't know. The other thing is that I know that there are folks actively working on this, making plugins to do visual scripting, but it's not a built-in feature as far as I can tell. One of the biggest questions for me is thinking about using Godot for future console releases. I know W4, a Godot enterprise company co-founded by the creators of Godot, is releasing a tool for consoles, but I'm not exactly sure what the long-term roadmap has in store for integrating console support. Since, open source software doesn't really fit well with proprietary SDKs. It's possible, certainly, but it's not nearly as integrated as Unity. Although Unity has gone through 3 different versions of cloud-based collaboration tools since I've been working with it, there are no integrated tools for team-based development for Godot. I've used Git in the past to share projects between computers with some mixed results, since there's a cap on file transfers and 3D models tend to go over that cap. And I've tried using LFS or large file system to mitigate this issue, but again, I'm not a computer science person and haven't really figured out how this process works just yet. Godot is still, the underdog, and for a lot of industry folks I've talked to, they think working in Godot is quaint. And I think that this is changing. There's been a whole new generation of folks coming to Godot from Unity, amidst recent news, but publishers in particular have been a bit skittish around Godot as an engine. Again, I think that's because there's a lot of unknowns when it comes to porting and licensing, and hopefully some of that stuff gets resolved soon. A minor thing that I've encountered in Godot is that sometimes it can struggle with obscure and proprietary file formats. Although it's working on native integration for a lot of different files, especially .blend files in my case, I had to undergo jumping over the hurdle of understanding what file types Godot quote-unquote prefers. Now, a lot of these are open source codecs and non-specific file types like OBJ or .wave. I've been able to adapt all of my workflow pretty easily once I read through the documentation a bit. Lastly, and this probably sounds a bit weird, but Godot is open source. So it's still very much in development, and major release cycles tend to be longer than competitors, though for 4, that's kind of changing a little bit. Even though I find it's a very holistic piece of software, like I said, there's still major development features that feel a long way off. The upside to this is, of course, that the core dev team seems very much aware of these issues and is very responsive to feedback. Okay, so that's it. Go use Godot. It's great. But truly, I I do find it's a fantastic option for solo developers to build projects big and small, and it's cured me of my fear of the blank canvas. If anyone decides to pick it up and give it a go, I'd love to see what you're working on, and definitely feel free to reach out or leave a comment below. Anyways, thanks for joining me, and I hope that you found this useful. Take care. Bye.